Hi there. The purpose of this video is to show you how to use Google Drive, in this case specifically Google Sheets, to do some sort of a linear regression or line straightening technique when you have a set of data. I'm looking specifically at a problem involving Coulomb's law type experiment, but you can use this technique for any sort of data that you're trying to do that linear regression for. Now the first thing I'm going to do is just go in and name my spreadsheet so that later on I can find it. No big deal about that. And just remember that anybody that has a Gmail account, any sort of a Google account, you've got free access to all of this, so that's why it's quite helpful. Also, the ability to be able to share documents is really handy. Now what I'm going to do is I'm going to put in a set of make-believe data that I've got here, and I'm going to specifically label my columns just so that later on, if I choose to put this data into a document, I can use it pretty much as is and use it as the observations table that I've got or something like that. So I'm just going to put in these numbers, and just remember I'm not just pulling these out of the air. This would be some actual data that maybe I've collected while doing an experiment. So I've got the force measured in newtons, and then I've got the distance between the two charges that I'm looking at measured in meters. So I'm just going to get all of this put in like that. Now the problem with this is if I graph the data as is, I would actually get a curved line. I wouldn't be able to do a linear regression off of it right now. I wouldn't be able to analyze it. So thinking back to Coulomb's law specifically, we know that that formula shows us that the electrostatic force equals Coulomb's constant times the two charges divided by the distance between them squared. It's an inverse square law. Looking at the data that I've got the force, which I don't have to worry about changing, but it's the distance between the two charges. Right now, that's all that it is, and I need the inverse of the square of those distances. So in column C, I'm doing this pretty much for my own benefit right now. This doesn't really do anything. I'm putting in that this is 1 over r squared, and remember, to do that little hat symbol, you're hitting Shift 6 to be able to get to it. And then down here, oh sorry, I almost forgot, I need to put in my units. The other way you can type in something like an inverse squared power is to the power of -2. So just to save myself a little bit of worry here, I'm going to say that the units are meters to the power of -2. Now in this box right here, what I need to show is that I need this box to be equal to whatever is in this box, inverse of it, and then squared. So I'm going to say 1 divided by, I'm going to click on this box, and you can see it puts in B2 here because it's reading that box as the one that I've selected. Then I'm going to hit Shift 6 to get the little hat symbol and square that. I hit enter, and no big surprise, it's just saying 1 inverse and then squared is still 1. We go back on top of it, and you can see this little square appears on that cell. So what I'm going to do is go right on top of that and click and drag down to fill in all of my boxes there with a formula that corresponds to whatever is in this box next to it. So you can see this is now saying B3 instead of B2. If I look at the one underneath it, B4, B5, and so on and so on. Especially if I'm dealing with a very large set of data, this is really helpful. Now there's something I'm going to do here just because it's worthwhile for me if I'm going to be doing a graph in this. I'm going to actually recopy over everything that's in these boxes, which I know sounds kind of silly because I went to all the effort of typing it in. That might just be because this was the way the data was given to me, force and then the distance between the charges. But the reason I'm doing that is because the important thing for me is that these are my x values and these are my y values. If I think about a regular sort of graph that I would be doing, I need to have the y values as my dependent variable, and it's going to be, you know, hey, what did the force do as I was moving these charges around to very specific distances, my independent variable. And so what I want to do is keep 1 over r squared as my independent variable on the x-axis. Putting the x and y down here, trust me, means absolutely nothing. It's maybe just a little reminder for me again, but it's not going to do anything else. Now if I wanted to get this graphed, what I would do is click on and highlight from here, click and drag down across all of this. Now this is the reason why I need to have the x data and then the y data, because when I insert the graph in a moment, Google Drive is going to look at all of my values in the first column is my x values, then everything in the second column is my y values. To insert that graph, I can go over here, and I don't really like this because they say insert chart, and to me what I've just done is a chart. I'm inserting a graph. But I can also go here to insert, and again choose insert chart from here, and I get asked a whole bunch of questions. Now in here you need to make some selections. First thing I'm going to do is go over to charts and change the type that this is. I'm going to change it over to a scatter graph, and I'm going to choose the top one. And then what I'm going to do is go in and customize. This is where I can do things like give myself a chart title, and I'm going to change it to force as a function of inverse squared distance. Okay, that'll be okay. It inserts this legend thing sometimes, and it really serves no purpose to us because we've only got one set of data, so I'm going to say none. You can also see over here it's updating sort of a preview of things for me as I go along. I get down here to where it says axis, horizontal. My horizontal axis is inverse squared distance. And I'm going to put in again that those units are meters to the power of -2 because it's an inverse square. Once I've got that, I'm going to go and change to the left vertical axis, and I'm going to put in that this is force measured in newtons. And basically I'm pretty happy with this now. This is a perfectly fine graph. One thing that is distinctly missing, at least for the time being, from Sheets in Google Drive is the ability though to get this to draw a line of best fit for us, a trend line, and to show us the equation of that. So as it is right now, this is all I can really do for a graph. Granted, I could physically go in, once I've maybe copied and pasted this into a lab document, I could go in and physically draw a line across it, but within this, there's right now, right here, nothing else I can do. So the important thing that I'm looking at is that probably from this data that I've got back over here, the information that I really need is the slope of the line and the intercept. Now what I usually do, and again I'm not choosing these boxes for any important reason, is I'm just putting in some notes for myself that what I'm going to be showing in these boxes soon are going to be slopes and intercepts to the actually to the right here, and I'm just aligning this just so it looks better. I'd already chosen for all of this stuff up here to go with center alignment just because I think it looks better. But down here, and again, this box, there's nothing special about it. It has to be in exactly this spot or something. All I'm going to do now is choose to start making whatever is in this box equal to the slope. And you can see it's starting to try to help me out here. If I click on this, it'll give me some suggestions. But I know that if I open up the brackets, it's going to tell me even more. It wants the Y data first and then the X data. So this is my Y data. I click and drag down across it. Hit a comma. Click and drag down across my X data and close off my brackets. And that is my intercept. That is you can think of it as being the mathematically exact calculated value for the slope of a best fit line that would go on this graph. The next thing I want is the Y-intercept, and very specifically, oh, and I guess I should probably have typed that in here. I'm just going to go in and fix that really fast. The thing about doing a spreadsheet like this is the only intercept it ever wants to calculate for you is the Y-intercept. So that's the only one you're going to get. And then if you have to get an X-intercept, you'd have to use the straight line formula y equals mx plus b and just set your y value equal to 0 and then solve for whatever x would be, and that'll be your, or sorry, I should say your x equal to 0 and solve for y, and then you'll know. No, I've got that backwards again. Put in y equals 0, solve for x, you've got your x-intercept. I'm just getting all fuddled up here. So, equals intercept, and again, I have to open the brackets, choose my y values first, put in a comma, choose my x values second, close the brackets, hit enter, and there's my y-intercept value right there. So, for any sort of a graph, if this was what you needed, you're basically set. One thing that I quite often do, if I'm going to be moving this over into a document by copying and pasting it, is I will go up here and I'll just choose that I want borders, grid lines all the way across. It just means that later on, if you copy this over, instead of a bunch of numbers kind of floating around, it gives them some nice boxes, gives it a slightly nicer feel for when it's appearing in a document. Hope this helps you out, and if you have any questions, just let me know.